for people and to infrastructures in New Zealand. This is where metal 3D printing can make a major impact by designing better seismic dampeners than traditional manufacturing methods can produce. The common seismic dampeners found today can be costly, hard to implement into structural designs. With the metal 3D printing process known as arc direct energy deposition that utilizes a high energy arc to layer metal filament layer by layer, we can manufacture large complex parts that can be easily tailored to fit into structural components for less tooling costs and less material waste. To capture the full potential of arc direct energy metal 3D printing, we chose to manufacture a friction spring dampener. This works a lot like a hydraulic to remove energy with displacement and friction. So far, we are modeling a simple friction spring to understand the capacities and to gauge the dimensions needed for manufacturing. Doing this will allow us to understand the key features that we can expand upon to create a better design. By the end of the project, we hope to have manufactured a simple friction spring that proves arc direct energy deposition has the capacity to manufacture structural components. We also wish to design a new friction spring dampener system that uses all the capabilities of metal 3D printing to make a friction spring that can be used in a range of different buildings to improve their earthquake resiliency. Thank you.